Hi, my name is Vincent. I am a machine learning engineer over at Explosion and one of the core developers behind Prodigy, the data annotation tool that's built for developers. Recently, we added support for a new feature to Prodigy, one that allows you to have models that interact with Prodigy as if they are annotators. And that opens up a new and powerful pattern, because this allows you to focus on examples where models disagree. And by using the disagreement between two models, we might be able to focus in on examples that are worth annotating first. And this is something I would like to demo in this video. I'm going to show you all the code in just a bit, but first what I would like to do is just do a little bit of diagramming, just to help explain what exactly we'll be doing in this video. Alright, so let's diagram out some general thoughts. Let's say that I'm working on a machine learning problem. And in this machine learning problem, I have two models at my disposal. And I'm just going to call them Model 1 and Model 2. These could be machine learning pipelines for named entity recognition. It could also just be a classification task. That doesn't matter so much, but the main argument here is that I have two models that are, let's say, different in the way that they work, but they are both useful. They both have some measure of accuracy, and I'm going to assume that these models aren't necessarily perfect, but they might be good enough for some application, let's say. Well then, at this point, given these two models, I'm able to pass a example to both, and this would give me two predictions. One from the first model and one from the second model. And let's now also say that the examples that I'm passing into these models are examples that haven't been annotated yet. And I actually have a pretty big stream of all of these examples that I could just pass to these models. Well then, even if there's no human in the loop, one thing that I can say is whether or not these two models agree. And from here, I can kind of wonder what it means if the models disagree. Because if you think about it, something interesting might actually be happening. When two models disagree, it could be that one of them is actually correct and the other one is wrong. And if that's the case, then either from this example that I have, I'm going to have an improvement for my first model, or for my second one. Another thing that could be the case is that both models are wrong, but in that case, I might have an improvement for both models as well, so that would also just still be an example I would like to inspect manually. The gut feeling here is that if you have a couple of models and if they tend to disagree, then the examples that come out might be interesting examples to prioritize for annotation. And it just so happens that inside of Prodigy, we have a review recipe that can do just this. It's just that the review recipe is designed to review annotators. So the main thing that we're going to do now is we're going to have two models here that are going to behave as if they are annotators, such that afterwards we are able to use the review recipe to prioritize examples where these two models disagree. And one thing about this approach that makes it relatively general is that we don't necessarily have to care too much about how these models work, as long as they are just models that are somewhat reasonable. So I could have a custom model that I completely trained from scratch, using the Prodigy train command. That's something I could have. Alternatively, I could also just have a pre-trained spacy model. So EN Core WebMD might be a candidate for that. But what I can also do is use spacy-LLM to construct a prompt with a definition of a task, and then have a large language model help me to also get this model ready. And that's kind of nice, because that means that if you have a pipeline already, it should be relatively easy to come up with another pipeline that you can compare against. And that means that if you're just getting started, we now have a somewhat general technique to find examples worth annotating first. And that's a pretty interesting pattern, I think. So as a demo, what I'm going to do is I'm going to show you how you might be able to set this up for named entity recognition. And I'm just going to be using the spacy pre-trained model as well as an LLM to use as my Model 1 and my Model 2. But it will be good to emphasize that while this video will mainly cover named entity recognition, the recipes inside of Prodigy will also work for text classification as well as for span categorization as well. So with that out of the way, let's do some code. Okay, So what I've got now is this examples.jsonl file that basically just contains a couple of headlines from the New York Times. And what I'm interested in is I'm interested in detecting names of people. So Tim O'Reilly over here, there will be a name of a person that I'm interested in. But I'm also interested in detecting organizations. So Alibaba, for example, that's an organization. I would like to detect that as well. So to help me with that, I would like to leverage a pre-trained spacy model. And to be specific, I would like to use the English Core Web Medium model. This is a statistical model. It's not going to be perfect, but it should be pretty good at just detecting a couple of these items. And just to demonstrate that, I figured it might be good to first just show how that might work. And to do that, I'm going to be using NER correct, which is one of the base Prodigy recipes. And the main thing that it'll just allow me to show is just what predictions the spacy media model is making. So I'm telling it to use this examples.json file. I'm interested in the person and the org label that are in this model. And I don't want this pipeline to segment my text into new sentences, so that's an extra flag. But when I now run this, I should be able to show you what the predictions look like. All right, so I'm inside of Prodigy now. We can see the two labels are what we expect. And we can also see that the medium spacey model detected Bill Maher concert as a person. And that's partially correct. I mean, I would say if I were correcting this that Bill Maher is a person, but concert here is just coincidentally capitalized, probably because it's a news headline. I think Yahoo Comedy Channel, that might be an org, that feels fine, but we see that the model does something that's somewhat reasonable, but it's not perfect. And when I look at the next example, it does seem to get Tim O'Reilly to be correct here. That's a person. And over here, I think I see another example where it could perform better. So Alibaba is an organization. It wasn't able to catch that. So the model does a few things well. It's not necessarily perfect. But what I would like to do now is have this model make all of these annotations and save them in a database. Then I'm going to get another model to do the same thing. But the first thing I want to do now is have this medium spacey model store all of its predictions as annotations in the database. And for that, I'm going to be using one of the new recipes. And the recipe that I'll be using is the NER model-annotate recipe. This is the recipe that allows me to have a model pretend to be an annotator. I need to give it a couple of arguments. So the first one is the data set that I'm going to save these annotations into. Then next I am going to have to give it a spacey pipeline. So in this case, I'm going to pass it this pre-trained spacey media model, which I downloaded up front. And then I need to pass it the examples that I would like it to annotate, which I'm fetching from disk at this point. Then there are two more that I have to pass. One argument is the annotator name, quote unquote. So I'm going to call it spacey medium. And finally, I am able to pass the labels that I would like to use, which are person and organization. Note in this particular case that this model has a bunch of entities that it could be predicting, but here I'm just making it very clear that I'm only interested in detecting those two annotations. So I'm going to just go ahead and run this. I get to see this little progress bar, which is nice. But you can see now that there are a bunch of annotations made, and we should be able to confirm that by calling python-m prodigy db out. And we can just have a look at the annotations that are stored in the database this way. This will output all of that. And we can indeed see that there's a whole bunch of annotations in there. And maybe just for good measure, let's just have a look at the first annotation. And, we can pass that to a JQ to get a slightly nicer looking output. But the main thing that's important is that what we saw before in the user interface, this model selects Bill Maher concert as a person. That's now stored in our data set inside of Prodigy. So this is definitely something I can point the review recipe at later. And I guess like one more final thing that is also maybe good to observe is that the annotator and session ID have been set to spacy medium, which is one of the arguments that I passed. This is the name of the annotator, so to say. So okay, that's pretty cool. We have some annotations. For me, a good next step would be to leverage spacy-LLM to configure a nice little prompt to have a large language model backend to also add some of these annotations for us. Then I'll have two models that I can compare in the review recipe. So I'll go ahead and set that up now. All right, so I have a spacy-LLM config file in front of me now. This configuration will tell Spacy to make a pipeline with an LLM component, and that this LLM component needs to perform the spacy-NER task. There are a bunch of things that I've configured here. I have label definitions such that for each name over here, the LLM can have a little bit more context. I've also added some examples over here that will also be added to the prompt. But in short, this is a configuration file that will be able to communicate with an LLM in the backend, and then spacy-LLM will take care of all the prompt generation and parsing for me. For this demo, I am using the GPT 3.5 endpoint. You can definitely pick other endpoints if you would like. But in order to use this with the model annotate recipe, this entire config file needs to be stored on disk as a spacy pipeline. And to do that, we can make use of the spacy assemble command. In order for that to work, you have to point the assemble command to the config file, and then it will just save a folder with a spacy pipeline that you can refer to on disk. The one thing that in this case is good to know is that I am using an endpoint over here that requires me to set some environment variables. I have those in my .env file over here, but in order to make sure that those are loaded, I am using this .env library in Python. By calling .env run --, you can make sure that this command that follows has the environment variables from the .env file pre-configured. And note, if you're doing this yourself, definitely feel free to take the time to come up with a pretty reasonable prompt. But for demonstration purposes, I think this is good enough, so I'm just going to run this command. The pipeline is initialized. Look at all the logs here. And at the end, we can confirm that indeed we have something on disk, namely this EN-NER LLM demo. So what I can now do is I can look back at my history for the model annotate call that I had. And basically what I can just go ahead and do here is just make some minor changes. Instead of using encore web medium, I have to point it to the pipeline that I just saved on disk, and that folder was called EN-NER LLM demo. And then the other thing that I got to do is I got to give it a different name. Spacy-LLM I think will do. But there is one extra thing that I'll need to do for this particular recipe. And that is that I will also need to tell the recipe which components to actually go ahead and use. In a lot of spacy pipelines, a NER component would have the name NER. But in this case, you can call your NER component whatever you'd like, so I will need to be explicit and actually give it the LLM name in this particular case. So I'm almost ready to run this. There is one final thing that I shouldn't forget, and that's again the .env run prefix. And again, that's because I'm using an LLM. And the LLM needs to know who I am because I'm calling to a vendor. So that means that I need my environment variables loaded. This is something you shouldn't forget because otherwise you'll get an error. All right, so this is now running. You will notice that it's a fair bit slower than the local spacy model. This makes sense. A large language model is more compute intense. And also we are making lots of requests over the network, which also cause a little bit of overhead. But what I'll just do now is I'll just let this run, and I'll pick it up when it's ready. And there we are. For about 180 examples, it took about 2 minutes, so, relatively slow, but not the worst. Now, I think the more interesting thing to do is to run the review recipe. And again, that's to show that we can now compare two models as if they are annotators. And here's a call to the review recipe that does just that. The review recipe first needs to have a data set that we're going to save the reviewed examples into. So NER news headline underscore final seems fine. Then we need to give it the data sets that contain the annotations we want to review. Both models save their annotations in NER news headlines demo. And then finally, I am giving it the labels that I would like to use explicitly, and I'm also making it clear to the review recipe that I would like to leverage the NER manual interface. There are some extra settings that I could set, but let's just have a look at this just to give a bit of a feeling of what the review recipe can give us now. And when I now load up the review recipe, you can see that I have this interface over here, that I have these labels that I can select. And then here on top is the final annotation that I, the reviewer, can declare. But below that, you can actually see what the spacy medium recipe did and what the spacy-LLM model did. And this example, I think, is pretty interesting because the spacy model, in this particular case, I think, probably did a better job on the organization. It depends a bit on the context, of course, but I could argue that in this particular case, maybe the Yahoo Comedy Channel is an organization on its own, so maybe we should prefer this annotation. But the LLM did a better job on the person's name, because concert should not be part of the name here. So, by coincidence, we've now stumbled upon an example where two models disagree, and I could go ahead and correct it, so let's just do that. But sometimes you will also see these examples where both models agree. I guess you could say this is a relatively simple example. Tim O'Reilly, that's a person, and the spelling seems nice and all that, so it doesn't surprise me too much that both models got this right. But here's another example where the spacy model could have done better, and the spacy-LLM model is able to pick up that Alibaba is an organization. And if I had to guess, I might also know a reason for this. Maybe the spacy model is using a corpus that doesn't have the Alibaba appear as a company. That might be a reason for this. But either way, the main thing that I think is pretty interesting here is that if we're collecting training data for our own custom model also to train locally, then it does indeed seem that the examples where there's disagreement, that those are the examples we want to see first. So with that in mind, let's run this with one more setting. I'm going to go back to the review recipe call here. I'll cancel the server. And what I'm going to go ahead and do is add this one extra flag to auto accept. And what this is going to do is it's going to say, well, when both models agree, just automatically accept the annotation, no need for a review. And if I were now to rerun this, then you can see that we have this one example where two models disagreed. So again, I can make this correction. And before, the second example had the Tim O'Reilly name that both models got correct. But you'll notice that that example is now skipped. That example now no longer makes an appearance in this stream, which means that I can focus on the examples where the two models disagree. And this, I think, is a pretty nice and powerful pattern. The reason why I think this is so interesting is because it's pretty easy to make a spacy-LLM model. You just need to have a prompt and some label definitions. But it is relatively easy to get a second model out there. If you have your own model and a spacy-LLM model, you could assume that they're both pretty good. But when these two models disagree, you will have interesting examples to prioritize. And that means that you don't have to go through every single example. You can just focus on examples where one of these two models might be getting it wrong. And that's a pretty powerful pattern if you think about it. Now, what I hope is that you find this approach interesting and that you might be willing to give it a spin. Before you do, though, there are a couple of bits of advice that I do think are fair to share. For starters, this auto-accept flag can be very useful, but it is also good to admit that there is a risk involved here. It is possible that you have two models that agree on an example, but are still wrong nonetheless. And by automatically accepting these examples, you may introduce some training data that you don't want to have. And that's just good to keep in the back of your mind. Also, while it is relatively straightforward to use spacy-LLM to construct your own models, it is also fair to mention that these models can be somewhat costly to run. If you use a vendor, you are going to have to pay for each request. And you also saw that it can take a while before you have all of your examples annotated, because large language models do tend to use a lot of compute power, and they do tend to be just a little bit slower. With that in mind, it might also be good to take a step back and to wonder what other models you might be able to use. After all, if you're doing named entity recognition, you can also come up with a spacy model that uses pattern matching. Maybe you already have a long list of names and organizations that you want to check against, and that can be turned into a spacy model as well. The recipes will work with any local spacy model, including custom ones that use pattern matching under the hood. Likewise, instead of using an LLM, it might also be interesting to think about pre-trained models. You could check out the Spacy universe, or maybe Hugging Face, and you could see if maybe there are some pre-trained models that you can use as well. It is really possible to get creative with this, but I suppose the final thing that's also good to mention is that in the end, this technique is still a bit of a trick. While you are able to use models as annotators, and while this trick can then help you be more productive as an annotator yourself, I would still argue that it's very important to keep the human in the loop. By exposing yourself to your own data while annotating, you typically learn a lot from your problem, and those tend to be very important lessons that you'll typically miss if you just automate everything with pre-trained models. Having said that, I do hope that this recipe proves useful to you, and we're definitely interested in feedback. If you have any, check out our Prodigy forum, and feel free to ask us anything.